All right, P5, we're talking about linear equations in two variables. So we're going to talk about lines. So with lines, we use slope. We have two variables in our linear equation. The simplest form of writing it would be this, y equals mx plus b. So anything written in this form is linear, where m is our slope and b is the y-intercept. So if we had a graph, b is where we cross the y-axis. The next page talks about slopes. So if our line is increasing, we have a positive slope. If our line is decreasing, the slope is negative. You can read graphs just like how you read a sentence going from left to right. So one way to think about it is if I was standing at the left side of my graph and I'm walking uphill, I'd be increasing, so I have positive slope. If I was standing at the left side of my graph, so we read a graph from left to right, just like a book, we'd be walking downhill here, so we'd be decreasing, which means we have negative slope. And we have two other types of slope with graphs. So if I had a line that was horizontal, what would our slope be here? Anybody know? 0. Awesome. Our slope would be 0. This line would be x equals or y equals? Y equals. It crosses the y-axis. It intercepts the y-axis, so it would be y equals. And it would be y equals whatever number it crosses the y-axis at. And then we could also have a vertical line. What's our slope of a vertical line? Undefined. Awesome. And then our vertical line would be x equals. So it'd be x equals whatever number it intersects the x-axis at. So because it touches the x-axis, it's x equals. One way to remember the difference from these two is if you look at 0, the z is kind of like horizontal, whereas undefined, the n is like a vertical line. It's kind of a helpful hint, a little trick to help you remember which one's which. So our slope tells us the steepness of the line. So this is our slope-intercept form, which says on the next page. So here, our slope-intercept form of the equation of a line is y equals mx plus b. So you've got your slope and your y-intercept. So slope-intercept form. On the next page, if you have a vertical line, it's x equals whatever number your x value is. So here, our vertical line goes through 3, so our equation of the line would be x equals. So if you have a vertical line, it can't be written in the form of y equals mx plus b. You just got to know that it's x equals if it's a vertical line, because your slope is undefined. And then similarly, if I had a horizontal line, let's say our horizontal line went through 3, this would be y equals 3. All right, example 1, we want to sketch the graph of each line. So for A, it's in slope-intercept form, so you always want to start with your y-intercept. So we cross the y-axis at 1. So I'm going to put a point at 1. And then our slope is 2. So one way that we can graph the slope is just by counting our rise over run. So we can make it a fraction, put it 2 over 1. So we got rise over run. We go up 2 to the right 1. Since 2 is a positive number, just double check that your line is increasing to make sure you put your slope in the right direction. You really only need 2 points on your graph to draw a straight line. If you want to keep going and put another point, keep going up 2 to the right 1, up 2 to the right 1. You can put as many points as you want. All right, how would we graph the line of y equals 2? Awesome. Straight across. Our y-intercept is 2, so we cross the y-axis at 2, and we put a horizontal line through 2. And then in C, it's easier to graph a line when it's in y-intercept or slope-intercept form as y equals mx plus b, so we can rearrange this equation to put it in y equals mx plus b, subtract x to move it to the other side, we get y equals negative x plus 2. So what's our y-intercept? 2, we cross the y-axis at 2. And what's our slope? Our slope is negative 1, so we could say negative 1 over 1, where we have our rise over run. So since our rise is negative, I'm going to go down 1 and to the right 1. Down 1 and to the right 1. Our slope is negative, so we need to make sure that our line is decreasing if we're going to draw it correctly. So you can always just double check. Since your slope's negative, your line needs to be decreasing. If your slope's positive, your line's going to be increasing. Next page just talks about how to find slope, which we have our equation on the following page. So here's our equation for the slope. Going through 2 points, we can find our slope by finding the change in y over the change in x. So this little symbol, this triangle, stands for the change in y over the change in x. Or, as we know it better, as y2 minus y1 over x2 minus x1. Now, when you're picking your points for x1, y1, x2, y2, the order doesn't matter. So on the next page, it says you can do y2 minus y1 over x2 minus x1, or if you switch the order, you could do y1 minus y2 over x1 minus x2, as long as you're consistent. You just can't do y2 minus y1 over x1 minus x2. So notice how here we start with the 2's, or start with the 1's. This one, it starts with different. So you can't start with different terms. If you start with the second point, for the y, you got to start with the second point for the x. So you just have to make sure you're consistent. So the order doesn't matter. That's why it doesn't matter which one you label as your x1 or your x2. Just make sure you're consistent with it. So we're going to find the slope of a line passing through each point. So let's look at A. I'm going to label my points as x1, y1, x2, y2, and plug them in. So change in y's over the change in x. So I'm going to say y2 minus y1, 1 minus 0, over x2 minus x1, 3 minus negative 2. 1 minus 0 would be 1. What's 3 minus negative 2? 5. Awesome. The minus a negative turns into a plus. So this would be 5. So our slope would be 1 over 5. This is positive slope, so our line would be increasing. Let's look at the second one, B. So I'm going to label my points x1, y1, x2, y2. y2 minus y1 would be 2 minus 2 over x2 minus x1, 2 minus negative 1. 2 minus 2 is 0. 2 minus negative 1, this turns into a plus, so this would be 3. What does 0 over 3 simplify to? What is 0 over 3? 0. So what would this line look like if our slope was 0? Horizontal or vertical? Horizontal. So remember, if you have 0 over a number, this simplifies to 0. If you have any number over 0, this would simplify to undefined. So if your 0 is in the denominator, it's undefined. So again, here we have the equation for the slope, and then right below it, we have point slope form. So another form for our equation of a line is point slope. So we usually like to work with this one if we're given a point and the slope. So again, on the next page is the equation of our line in point slope form. So example 3 says find the slope-intercept form of the equation of a line that has a slope of 3 and passes through the point 1, negative 2. So there's a couple different ways that we could do this. Since we're given the point and the slope, we can use point slope form. So my slope is m. My point's going to be x1, y1. So I'd say y minus y1, so minus negative 2, is equal to m, which is 3, times x minus x1, so x minus 1. This question says find the slope-intercept form. Is this slope-intercept form? No, slope-intercept form is y equals mx plus b. How would I rearrange this equation to put it in y equals mx plus b? Distribute the 3. And then I can also change this to plus. So y plus 2 is equal to 3x minus 3. What would I do next? Subtract 2. We want to get the y by itself. So y is equal to 3x minus 5. So this would be our equation of a line in slope-intercept form. Questions? So this way is doing it in point slope form, or working with point slope form. We could do it another way. Just in case you happen to forget what point slope form is, we can do this in slope-intercept form. So y equals mx plus b. Our m is 3, x plus b. Here we don't know what our b is. We don't know what the y-intercept is. But do I know what x and y are? What's x? 1. And y? Negative 2. I can use this point as x and y. And I can plug it in and then find b. So I have negative 2 is equal to 3 times 1 plus b. So negative 2 is equal to 3 plus b. Subtract 3. Negative 5 is equal to b. So now that we have our y-intercept, I'd say y is equal to 3x minus 5. So we just keep our slope and our y-intercept plugged in. So 2 different ways of doing the same thing. So here, it's called 2-point form, but it's just you're finding the slope before you plug it into the equation. So here it gives us 2 points. We want to find the slope first before we come up with our equation of a line. Because your equation of a line, you need your slope, so you have to find the slope first. How do we find the slope? Awesome. y2 minus y1 over x2 minus x1. So I'm going to label my points as x1, y1, x2, y2. So 5 minus 3 over 2 minus 1. So we get 2 over 1, which is just 2. So that's our slope. We need to come up with the equation of a line. Do you want to put it in point slope form, or do you want to work with slope-intercept form? What do you want to do? Sure, let's do it in slope-intercept form. So y is equal to, our slope is 2, so 2x plus b. What could I plug in for x and y here? Sure, either one. You could work with your x1, y1, or your x2, y2. Doesn't matter. You'll get the same answer no matter which point you use. So 5 is equal to 2 times 2 plus b. So 5 is equal to 4 plus b, subtract 4, b is equal to 1. So when you plug that into our equation, we get y equals to x plus 1. Next, we're going to talk about parallel and perpendicular lines. So two lines are parallel if their slopes are equal. So parallel, we have the same slope. Perpendicular if their slopes are negative reciprocals, or we would say opposite reciprocals. Meaning that if one of the slopes is positive, the other one's going to be negative. Or if our first slope's negative, if it's perpendicular, the next slope's going to be positive. So in example 4, we want to find the slope-intercept forms of the equation of the lines that pass through the point 2, -1, and are parallel to and perpendicular to the line 2x minus 3y is equal to 5. So let's start with parallel. This is asking us for two separate lines. So let's start with the line that's parallel to this. Well, if it's parallel, what do we know about the slopes? They're the same. How do I know what the slope is here? Do what? How do I know what the slope is? Well, it's the same, but how do I know it's the same as what? So here, it gives us the equation of line. Can I clearly see what my slope is? No. We want to isolate the y, so I want to put it in slope-intercept form. So that way, whatever's in front of the x, once it's in slope-intercept form, that would be my slope. So I'm going to subtract the 2x over. So -3y is equal to -2x plus 5. And then divide by -3. So y is equal to 2 over 3x minus 5 over 3. Now the only thing I care about here is the slope. The rest of the equation does not matter. So my slope is 2 over 3. And we said if our line's parallel to this one, our slope is going to be the same. So for A, we're using the same slope. Our slope would be 2 over 3. Do you want to, we have to leave it in slope-intercept form, but do you want to put it in slope-intercept form or point-slope form to find our new equation? You can pick whichever one. Sure, we can work with slope-intercept. It gives us the point and our slope. So we have y is equal to 2 over 3x plus b. We don't know what b is yet, so we have to find it. What's x and y? What's x? 2, and y is -1. Perfect. We're using our point and plugging it in. So -1 is equal to 2 over 3 times 2 plus b. So -1 is equal to 4 over 3 plus b. I'm going to subtract 4 over 3 to move it to the other side. So we get, I'll do it here, -1 minus 4 over 3. If we're adding fractions, what do we need? Or subtracting fractions, what do we need? Common denominator. So I'm going to make it 1 over 1 and change it to be 3 over 3. So we get -7 over 3. So b is -7 over 3. Now when I write my equation of a line, I'm just plugging in my slope and my y-intercept. So y is equal to 2 over 3x plus, minus, because it's negative, -7 over 3. Next, let's find the line that's perpendicular to the given line. What do we know about the slope of our new line here that's perpendicular? It's the opposite reciprocal. So what is the opposite reciprocal of 2 over 3? Awesome, -3 over 2. We change the sign and we flip it. So change the sign and flip the number. You're taking the reciprocal, so you got to flip it. Do you want to do it the same way with slope-intercept form, or do you want to use point-slope form here? You guys can pick. What do you want to do? Let's use point slope. We'll try something different. You're going to end up with the same answer. So if you want to work with slope-intercept form and see that you end up with the same answer, that's fine. It's just two ways of doing the same thing. So our point slope form is y minus y1. So y minus -1 is equal to m, which is -3/2, times x minus x1, which is 2. We want to put this in slope-intercept form. So what would we do first? Distribute. And y minus -1 turns into a plus. So this would be y plus 1 is equal to -3/2x. What is -3/2 times -2? Awesome. Plus 3. Last step, subtract the 1. So y equals -3/2x plus 2. So next page talks about applications. So it says in real life problems, the slope of a line can be interpreted either as a ratio or rate. If the x-axis and the y-axis have the same unit of measure, the slope has no units and it's a ratio. If x and y have different units of measure, it would be a rate or rate of change. So rate of change, ratio, and slope are all talking about the same thing. So on the next page, the maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. Is the ramp steeper than recommended? So first we want to find out what proportion we have here, what ratio our ramp actually is. So it's 22 inches tall, bless you. So that would be our y, 22, over 24 feet. Now these are different units of measure. So we want to change our feet to be inches. How would I change 24 feet to be in inches? Do what? How do I convert it? Yeah, that works. So, I mean, we're technically just multiplying 24 times 12, right? Yeah. So 24 times 12 would be 288. So our ratio would be 22 over 288. Can I simplify this a little bit? What goes into both 22 and 288? 2. So it'd be 11 over 144. Now we want to compare this to 1/12. It says the maximum recommended slope of a wheelchair ramp is 1/12. We want to see if our ramp is steeper than what's recommended. So I'm comparing the two of these. It's hard to compare them when our denominators are different, so let's make them the same. What do I need to multiply to 12 to give it a denominator of 144? 12. So we have 11 over 144. We're comparing that to 12 over 144. So if 11 over 144 is less than 12 over 144, this was our recommended. If the slope of our ramp is less than, would it be steeper than recommended? If our slope is less than, is it steeper? What would the slope of a line, a steep line like this be versus a line like this? Which one's steeper? The first one would be steeper, and the slope would be more. The slope would be higher. So if it's less than, is it steeper than recommended? No. Not steeper. All right, in example 6, it says the sales for Best Buy were approximately 35.9 billion in 2006 and 40 billion in 2007. Using only this information, write a linear equation that gives the sales in billions of dollars in terms of the year. Then predict the sales for 2012. So we want to come up with our equation of our line. So anytime we have a real life, real life values, time is always going to be our x. Time is our x. So we could use the two things that were given, so 35.9 billion in 2006, we can come up with a point. So it'd be 2006, comma, 35.9. And then our other point would be 2007, comma, 40 billion, so 40. So if we're coming up with an equation of a line, because it said that these are linear, coming up with a linear equation, first we want to find the slope. So I'm going to say y2 minus y1. I'll call this x1, y1, x2, y2. So y2 minus y1 would be 40 minus 35.9 over 2007 minus 2006. So our slope would be 4.1 over 1, or just 4.1. So when we write this as an equation of a line, we'd say y, you can use whichever point you want. I'll use the second one just because the numbers are a little bit nicer. So y minus y1 would be 40 is equal to 4.1 times x minus x1, which is 2007. So it doesn't specify what type of equation, it just says come up with an equation. So this would work if we were going to predict the sales for 2012. What would we do? How would we predict the sales for 2012? Into what? Awesome, we plug in 2012 into the x. So y minus 40 is equal to 4.1 times 2012 minus 2007. So y minus 40 is equal to 4.1 times 5. Y minus 40 is 4.1 times 5 would be 20.5. And then add 40. So our y would be 60.5 billion. All right, the last page we have our equations of lines. So general form is a times x plus b times y plus c is equal to 0. So it's when all of your terms are on the left side and it's equal to 0. Vertical line is x equals, horizontal line is y equals, slope-intercept form is our favorite, y equals mx plus b. Point slope form, y minus y1 is equal to m times x minus x1. And then 2-point form is the same as point slope form. It just has your slope written out as y2 minus y1. So I would say don't worry about point slope form because it's the same as. Don't worry about 2-point form, it's the same as point slope form.